Now that you are good with the decision variables, let's go to the next step of developing our model that is about the objective function. Okay, I want you to try your best to get the best answer for these activities, because I believe you already have the answer for these activities, although it is a new section in chapter 6, but it's very similar to the previous one. So try your best to get the objective function. First question, the objective function that you are trying to do, is it a minimizing or maximizing? Specify that, and also check the case another time to see what it is that you want to minimize or maximize. And when you do that, just according to the things that we have learned so far, try to write it down. So pause the video and do the things. Since it is asking you to do this activity without formulation, so you just, as I mentioned, just specify if it is minimizing or maximizing, and what is that you want to minimize or maximize. Let's check the answer together. Finishing the project in the minimum amount of time. So here we are doing a minimizing stuff, and what we want to minimize is the amount of time. In the next activity, it is asking you, okay, now write down the mathematical objective function. In fact, it is asking you to formalize the objective function. Remember, we have 9 decision variables. For each decision variables that talk about the potential assignment of a project leader to a project, there is a specific amount of time. For example, if you assign project leader 2 to project 3, it takes, for example, 10 days. So if you assign it, the decision variable would take 1 and 1 times that 10. If you don't do the assignment, it would be 0 and it has no effect in the objective function. Pause the video, take your time to get the answer. And here we go, we have the answer. The objective function is a minimizing, and we have 9 decision variable of x11, x12, x13 as we talked about, and you see the multiplication of the times taken to complete each project. For example, if you assign project leader 1 to project 1, it would take 10 days. If you assign project leader 1 to project 2, it would take 15. Let's check, for example, this one. It says if you assign project leader 2 to project 2, it would take 18 days. Let's check it together. If you assign, here we can see it. If you assign project leader 2 to project 2, you have that 18. It is coming from here. So it is the objective function. So now you have the objective function that I believe it is simpler than the transportation models, because the variables can only take 2 values. Okay, let's go to activity 5. Similar to the other network models, each node is associated with a constraint. Write the constraint of the 3 supply nodes on the left. So since it is a start point, it is asking you to start with the supply nodes. Let me give you this point also, my friends. It is telling you that when you are dealing with network models, each node that you see means a constraint. No matter if it is origin node, destination node, or transshipment node, you notice that for each constraint for each node there is a constraint. For example, for this we have a supply constraint, and here that we have on the right, here is a demand constraint. If there was a transshipment node, there would be a constraint as well over there. So the point that it is telling you is very helpful, that similar to the other network models, each node is associated with a constraint. Now here it is asking you to write the constraint regarding the three supply nodes. The supply nodes, for example, for node 1, it is x11, x12, x13, because they are related to supply 1. Okay, what happens with these things? Pause the video, think on that before I continue. Okay, now we are working on the constraint regarding the first supply. That is the first project leader. So x11 plus x12 plus x13. Since it is a supply constraint, it must be equal or smaller. And how many do we have? Just one. The same continues for the other two ones. And again, pause the video and try to write down the other ones after you saw this. And now here we are gonna check the other ones. Okay, here we have, as you can see, for the first project leader, we have x11, x12, x13, smaller or equal. It is for the second one, and in fact, it is the second supply constraint. And 2 that is common between all of them is talking about the second project leader. So we have x21, x22, plus x23 equal or smaller than 1. And the last one is about the third project leader. Assignment of third project leader to first project, third project leader to the second project, third project leader to the third project. Smaller or equal than 1. And remember, my friends, here when you have such a constraint, it is assuring that Terry is not being assigned to more than one project. Because, for example, if you assign Terry to project 1 and it gets 1, there is no way you can x12 and x13 take 1. Absolutely, those two others would be 0. So Terry would be assigned only to one project. So you see, it's the magic of mathematics that how handle different situation. Or for example, if you assign Terry to project 2, okay, it gets 1 and the other ones must take 0. So there is no way with this constraint any project leader will be assigned to more than one project. Okay, let's continue with the constraint of 3 demand nodes. And remember about the demand nodes that we had in the previous examples, and do it exactly in the same way. As always, pause the video to write the answer at your pace. Not at your pace, at your pace. Sorry for the typo in my talking. We have 3 demand nodes. For the first one, it would be x11, the project leader 1 is giving service to project 1, plus x21, the project leader 2 is giving service to the first project, and x31, because we are talking about the demand, and demand is about the project 1, and they must be equal to 1 because there is only one project. The same way goes with the other ones that we have. So we are going to see it in this slide. So you see x11, x12, x13. Okay, as you notice that, my friends, here we have a mistake. And let me see. Oh, okay. Here we have a mistake because they are not like this. It should be because it is about the first client, x11 plus x21 plus x31 equal to 1. And after that, it goes to the other one. It goes to x12, x22, x32, and finally it goes for the third client. So 1, 2, 3, and the third. So since it is the first client, this one is common, and it is absolutely not correct here. So correct it. And as you can see here, we have it x11, 21, 31. 11, 21, 31. That's correct. So here it is some sort of typo, more than typo here. And when we want to do for the second one, since it is about the second client, so when three project leader try to serve this project, it would be 1, 2, 2, 2, and 3, 2 equal to 1. And when it is for the first one, it is the first project leader, second project leader, and the third project leader to the first one. So absolutely, this one that you see is not correct. You can think on that more to get it better. And finally, we get to the whole model. So try to write down the whole model, including the decision variables that we discussed it in details, how to write down the decision variables while there are 0 and 1 variables, objective function, and the constraint. So write it down, and after that check it. And now we are going to see the whole model. As you can see here, combining the objective function and constraint into one model provides the following 9 variables. We talked about this. And 6 constraint linear we have. Okay, this is the objective function. We talked about it. And here are the supply constraint, and here are the demand constraint. And here, for example, it is the demand constraint for the 3-1 is correct. 1, 2, and 3, all of them serving the third one. And here we have first serving the 2, 2 serving the 2, and 3 serving the 2. And here, the one that over there was a mistake. 1 serving 1, 2 serving 1, and 3 serving 1. So here it is correct, and over there it was not correct. So check it to make sure this one is correct. So as you can see, x11, 21, 31. And when we go here, 1, 1, the first one is correct, but 2, 1 and 3, 1 are missed here. And that's the reason we remove it in that way, because it should be 2, 1 and 3, 1. And so you can see it in the whole model, it is correct. So now we are done with the assignment problems, my friends. All the cases who are in the assignment are following the same logic. So I really suggest you go for some more examples in your textbook, and if you have any question, you can forward the question to me and we can discuss them together. The reason on this point today we are not going to have classwork, because they are very similar to each other. As you can see, when I provide you with another assignment problem, it would be exactly the same. So it's just the difference is about the applications. Here we had project leaders and project. In the other one, we are going to have, for example, an agent and a client, and it's going to be like that. So I prefer to take the remaining time of our class for other things, so to increase the productivity of our classes. I hope now you have a good understanding of the network models, and agree with me that all of them are very similar, and just when you get the main point of a network model, you can do it, no matter if it's a transportation model, transshipment model, or assignment model.